The first step in analyzing forces is to choose the appropriate object, or to find the object that the forces are exerting on. So when you encounter a force problem, which objects are you going to choose? There are three choices. The first one being the mass point, and the second one, the system, the entire system, and the third one, the force bearing point. In the last lecture, we've mentioned about the free body diagram. To draw a free body diagram, what you do is you ignore the details and represent the entire object with a single mass point. The mass point, I'm just going to define what mass point is right here. The mass point is a single point where all the mass is concentrated in. Basically, we're going to treat the entire object like a single mass point. Now let's look at the detailed explanation for mass point. It says that for most of the questions, you must analyze all the objects and list the corresponding mathematical equation. What is the key word in the sentence? Here, I would like to ask everyone to find the key word in this sentence. I would suggest you to pause this video for a moment and look at this sentence carefully. Try to understand what it is trying to convey and then try to find a key word. I'll give you a second to think about this. Alright, the key word in this sentence is the word all. Why is the key word all? Well, it's pretty simple. Let's say that there are forces exerting on two objects. What do? Since the forces are exerting on both objects, you should analyze both objects. What if there are three objects? Well, you should also analyze all three of them. A lot of beginners get really excited once they solve for only one object and put that down as the answer when they really should be analyzing all the objects. The second method is by looking at all the objects as a system. So right here, a system. In the first method, we talked about how you have to analyze all the objects that the forces are exerting on. Let's say there are forces exerting on objects A, B, and C. You would analyze all three of them. However, you don't have to solve A, B, and C individually. You can look at the three objects as a system. How do you choose your system, however, depends on your experience. The more you practice, the more experience you get, and eventually you'll get a sense of how to choose a system that will lead you to the correct answer. I've listed a helpful tip right here, and it says that internal forces do not affect the motion of the entire system. What are internal forces? Well, internal forces are forces exchanged by the objects within the system. I'm going to write that down. Internal forces. So internal forces are forces exchanged by the objects within the system. Let's look at a quick example. Let's say we have two blocks right here. This block, we name it A, and another block that is in contact with A and call it B. Let's say we exert a force on block A from the left, right here, F1. Here, because block A is in contact with block B, and we also said that you have to analyze both objects since both of them are moving, in everyday sense, when you push this block A, B also moves with it. So B is also experiencing a force exerting on it. Alright, so because block A is in contact with block B, there is a force exerted on block B. So let's call this internal force, we call it F2, just to differentiate it from F1. Okay, next, Newton's third law, which we'll talk about in detail in later chapters, also said that there is an action and reaction between the blocks. So there is also a force pointing from B to A. So let's call this F3 right here. With all these forces pointing to one another, things can get really complicated. That's why I introduced the second method, by looking at these blocks as a system. Okay, so how do we look at this? Let's see that since block A will always be in contact with block B, can't we say that these blocks are just one big chunk of blocks? Okay, so we can basically look at these two blocks as a system. If we look at the two blocks as a system, then we can simplify the question. Well, you might then ask, what about the internal forces? What about the F2 and F3 in here? Don't you have to include them too? Well, this is where the tip comes in, right? Let's go back and look at it. It says, internal forces do not affect the motion of the entire system. Internal forces are forces exchanged by the objects within the system. Hence, we can ignore all these forces in the system and simply regard the two big chunks of blocks as just one mass point. So in this case, it will just be one force exerted on it as F1. And to draw these blocks as a mass point, because we want to draw a free body diagram, we can simply do like this. We can draw a dot right here, and then we say we have a force pointing it, starting from here and moving here, and that's called F1. Okay, now let's look at the third choice. The third choice is where the force bearing point is. Alright, let's take a example. Let's say we have a ceiling over here, and on the ceiling we're hanging an object. These are strings, and it comes together right here, and we hang an object at the bottom right here. Let's say the mass of this object is big M. Okay, so these are all strings. I'm going to draw it. These white parts, these are just all strings. Okay, the force bearing point would be this midpoint right here, where all the strings connected to each other. There are three forces acting on this point. There are two tensions forces up here, T1, another one here, T2, and another weight pointing downwards, and we call this mg, as we mentioned in earlier lectures. Alright, we'll be looking at some problems in later lectures. Okay, let's go back here. Overall, the main concept of this lecture is to find the appropriate object. If you choose to analyze the mass points, be sure to include all the objects. If you choose to analyze it as an entire system, remember that the internal forces do not affect the motion of the entire system. And last of all, you can choose to analyze the force bearing point. In the meantime, asking you to choose an appropriate object might be a bit daunting and vague. After all, how do you know whether the object you choose is appropriate or not? However, you don't have to worry. In later lectures, we're going to look at several problems so that you can develop a sense of how to choose the appropriate object. In the next lecture, we're going to talk about the second step in analyzing forces.